Welcome back to this channel, Learn and Steady. In this video, we'll be looking through chapter Force and Laws of Motion. In this chapter, I'm giving you some notes on this chapter. So let's get started. So first we have to know what is force. Force is the push or a pull on an object that produces an acceleration in the object is force, and its SI unit is Newton. So this is what is force. In this chapter, we'll be looking through Newton's three laws of motion, and balanced and unbalanced forces, and law of conservation of momentum. So let's get started. So first we have to know what is balanced forces. Two forces acting on an object are said to be balanced when they are equal in magnitude and opposite in direction. Then the net force acting on the object will be zero, and hence the forces do not produce any change in state of the object. In this picture, we see two people trying to push this object. But when they both are pushing this object in this opposite direction, they are applying a force on this object is same. So there is no change in its motion. Suppose if this person is applying 50 Newton and this person is also applying 50 Newton. So we know that the net force will be 0 Newton. So there won't be any change in the state of this object. And they are equal in magnitude and they are pushing it in opposite direction. So this is what is balanced forces. Now let's see what are unbalanced forces. When two forces acting on an object produce a change in state of the object, the forces are said to be unbalanced. There will be a net force acting on the object and the object moves in the direction of greater force. So let's have an example here. We see that there's a boy in the middle and one boy is pulling him from this left side and one girl is pushing him from the right side. Now, where will this boy go or move? Yes, he will move to this boy. Why? Because this boy is pulling with a force of 10 Newton and this girl is pulling with a force of 6 Newton. And we saw here that the object moves in the direction of greater forces. So here the greater force uh, uh, is like made by this boy. So he will be pulling this boy and this boy will move from here. And what will be the net force of this object? Yes, 10 minus 6, 4 Newton. So this is what is unbalanced forces. Now let's see what is Newton's laws of motion. We'll be looking Newton's first law, second law and third law of motion. So first let's see Newton's first law of motion. Newton's first law of motion states that an object remains in its state of rest or of uniform motion along a straight line unless it is compelled by an external unbalanced force. We see a ball rolling on this surface. So this ball will continue to move. But if we apply any force, so that force we apply is an external unbalanced force. So if we apply this external unbalanced force, this ball will come to rest. If you want to make it to rest, it will come to rest. Otherwise, this ball will continue to move and it will stop. Yes, it will stop by its own. So when it's stopping it by its own, there's no any other external unbalanced force. When we apply to stop this ball, there is an external unbalanced force. So this is what is Newton's first law of motion. First law of motion is also called law of inertia. We'll see what is inertia The first law defines force. Now, what is inertia? The natural tendency of an object to resist a change in its state of rest or of uniform motion is called, or along a straight line is called inertia. Now, let's have two examples of inertia. So, here we see that there's a passenger sitting in a bus. So, in this, the bus starts from rest and this bus was moving and it came to stop. Now, let's see of the first condition. So, when a bus at rest suddenly starts moving, the passengers sitting in it fall backwards. This is due to inertia of rest of the upper portion of our body. Now let's see in the second case. When a moving bus comes to a sudden halt, the passengers sitting in it fall forward. This is because when the bus comes to a sudden stop, the lower portion of our body comes to a state of rest, but the upper portion of our body still continues in its state of motion. It is because of the inertia of motion of the upper portion of our body that we fall forward. Now, let's see the relation between mass and inertia. Inertia is directly proportional to mass. The more the mass will be and the inertia of the object will be more, and hence greater force will be required to change the state of the object. The less the mass, the less will be the inertia, and the force required to change the state of the object is less. Now let's see Newton's second law of motion. The second law of motion states that the rate of change of momentum of an object is directly proportional to the external unbalanced force and takes place in the direction of force. Second law gives a method to measure the force acting on an object. The mathematical representation of Newton's second law is F is equals to m into A, where F is force, m is mass, A is acceleration. Now let's see Newton's third law of motion. To every action, there is an equal and opposite reaction. Action and reaction are forces. They are equal in magnitude and opposite in direction. Since action and reaction act on different objects, they do not cancel each other. Now let's have examples for Newton's third law of motion. So here we see that a man jumps forward from this boat to the shore. So now let's see what is the action and reaction. The action is the man exerts a force on the boat move backwards. That is the action. Now what is the reaction? The boat exerts an equal force to the man in opposite direction and hence man lands on the shore. Now let's see another example. A bullet fired from a gun. So the action is the bullet moves with velocity in forward direction. And the reaction is the gun recoil backwards. So these are the examples for Newton's third law of motion. Now let's see law of conservation of momentum. Total momentum before collision is equals to total momentum after collision. This is law of conservation of momentum. Now let's see a formula for law of conservation of momentum. ma into ua plus mb into ub is equals to ma into va plus mb into vb. Here M is the mass, A is the first object, U is the initial velocity, and B is the second object, and V is the final velocity. So this was the end of this video. Thanks for watching this video. If you found this video helpful, make sure you subscribe to this channel and hit the notification bell to get notified whenever we post new videos. Goodbye.